The last video for the lesson with inverses is how we can verify that two functions are indeed inverses of each other. So if you look at your assignment, we're going to check out number 19, and we're going to do number 19 first. Okay? Number 19 says that f of x equals x plus 6, and that g of x equals x minus 6. So my question is, are these two functions inverses of each other? Well, how do we find that out? Well, we pick one of the functions, and I'm just going to pick f, and we write it in this format. Remember, f of x, it's the same thing as y. So I'm going to write it as y equals x plus 6, okay? Now, to verify that this is in fact the inverse of this one, we're going to follow the same process we did on the previous video. We're going to switch our domain and range. So that's going to be written as x equals y plus 6. All I've done is switch the domain and the range, okay? So now let's solve it. I'm going to subtract 6 from both sides. And when I do that, I get x minus 6 on this side. Sorry, we have a rogue marker. And y on this side. So y equals x minus 6. Now, is that what we have up here? Do we have y equals x minus 6? Yes, we do. So you've just verified that these guys are inverses of each other. Okay? You took one of them and you found the inverse, and the inverse was the other function. So we just verified that the functions are inverses of each other. Okay? Now, sometimes they won't be. But in this case, I believe on this worksheet, they will all be inverses. You just have to verify that they are, in fact, inverses. So let's do one more. And I'm looking at one we can do. Let's do 22. That looks like a fun one, as you guys would say. So number 22, f of x equals 2x minus 7. And g of x equals x plus 7 over 2. So I want to verify that these are in fact inverses of each other. So I'm going to pick one of these two functions, and I'm just going to choose f of x, and I'm going to make it y equals 2x minus 7. Remember, f of x and y, same thing. I'm going to switch my domain and range. So this becomes x equals 2y minus 7. So let's solve it for y. I'm going to add 7 to both sides. That gives me x plus 7 equals 2y. And then my last step is to get a 1 in front of that y, so I'm going to divide both sides. And remember the whole thing by 2. So that leaves me with y equals x plus 7 divided by 2. Does that match this? Yes, it does. So that means, again, yes, they are inverses. And this is what you're going to be doing to verify that they actually are inverses of each other. So just a quick review. We're going to go back to the beginning. Inverse functions. An inverse function is a function that reverses another function, basically the domain and range switch. I gave you examples of mappings where the input became the output and the output became the input. So all the x's became the y's and all the y's became the x's. We went over inverse function notation. We looked at an example of inverse functions using coordinates, and this happens to be number 1 on your assignment. Okay? So then when we got done with that, we moved on to the finding of the inverses, and we did several from your assignment. So finding inverses. And basically, remember, for finding inverses, you know that the domain and range will switch. So I switch the x and y term, solve for y, and that's how you get your inverse. Okay? That's how you get your inverse. Now, we've got the same thing here. Switch your x and y. That's your inverse. So that's how we did the inverses. And the last thing we just did was actually verifying that two functions are inverses. If we would have solved and flipped here, and we would not have come up with x minus 6, then that would have told you that these two were not inverses. But in this case, they are. And I believe on your assignment, you're just verifying that they're all inverses. I think they are all inverses of each other. You just have to verify it. And that's inverse functions.